right, guys, so find the place for 2 1 notes in your packet. We are reviewing exponents in 2.1. So you guys have been seeing these exponent rules since Algebra 1, and you're very good at them when they're separated. It's when we put all of them together that sometimes things are a little rough. So let's review what they are. The first is the product property. I'm just going to give you an example of each so you remember what we're talking about. Let's say I have x cubed times x to the 4th. What do I get? X to the 7th. Good. Product property, we add our exponents, okay? Next one is our power of a power property. So what if it's x cubed to the 4th power? X to the 12th. Do you guys know, like, do you understand why these work, or do you just, like, have it memorized? I add, I multiply. Memorized? Can I show you why it works? So x cubed to the 4th, that means you have 4 of these, right?
Oh, yeah.
And then you can use the first property, or if you have just memorized that one, think about it. X cubed, that's x times x times x. How many x's do I have? 12, okay? So, like, there is reasoning behind this. It's not just we tell you to memorize, multiply, add, subtract, all of that. All right, quotient.
You just kept them going
Let's say we have x to the 5th, y to the 4th over x cubed, y to the 9th.
X to the 2nd over y to the 5th.
Good. This is what I mean, separate. You're good at them when it's just one property at a time, right? Like this is,
Yeah.
I won't say this is easy, but this is pretty easy so far. Like you remember this stuff? Okay, yeah. You're pretty good at it when it's separate. It's when I combine all of them and put coefficients in that then things get a little tricky. Okay. So yeah, with the quotient property, you are subtracting, or just think about, okay, how many x's do I have left? Where are they going to be? How many y's do I have left? Where are they going to be? Okay. All right. A 0 exponent. 0. What if I have 3 to the 0? It's 1. We have negative exponents. Let's say I have what's that going to become? X to the negative 3rd over y squared. Good. Let me give you one more of those. If I have so we'll combine a couple of rules here. A cubed over b squared all to the negative 7. Yeah, so you've got to flip everything and then multiply your exponent. So this is e to the fourth over 8 to the 6. Okay, your own space there. All right, so far so good, right? Okay, we also have rational exponents. What if you see x to the 3/4? What does that mean? You do not skip the problem.
The bottom one is the root.
Bottom one is the root. Yes. So this means the 4th root of x cubed. Or you could write it this way, the 4th root of x and the whole thing cubed. Those mean the same thing.
Oh, yeah.
Alright. We remember all of these individually, right? Okay, so let's look at examples of them. Let's do, so we're going to simplify to start with, okay? C to the 5th d cubed over c cubed d squared to the -2nd times c cubed d to the 4th over c to the -2nd d to the 5th all to the 3rd. Don't be scared. Do it in pieces, guys. Do you see how there's a lot of C's and D's in my parentheses? So could I maybe make what's inside the parentheses a little bit simpler first? Yes, let's do that. They are multiplied together. Do you want me to start, or you guys just want to try first? Okay, good. I think what messes you guys up the most is you try to do a lot of it at once and get kind of lost in the process. Do it in little pieces. It's not bad if you have to do it in little pieces, as long as you get to the end correctly, okay? Talk to your neighbor. Do you agree? Are you headed down the same road, or did you totally run away from each other? Yes.
So if it's negative, negative, you should go back.
Look at that, you know stuff. It's exciting.
How would you like my first? This side I'll do. Yeah.
This is fun. Yeah, this one I don't like.
And
This one, since it's negative, should actually be
it's like
I guess you did.
Yep.
Uh-oh. This is coming out. My answer is C, fifth, D,
There's several different ways you can get to the
Yeah, that basic addition.
Yes, it's I didn't finish.
Over you just spent.
Going up, I got it.
You haven't done anything.
Yeah, I went for it last week, so I talked about it. And all of them have different answers.
A puzzle, yeah. You're like, I'm doing this.
I don't know what I should get. So let me grab my keys out of here and we'll write it up. You guys all really disagree?
Yeah. Well, no, they all have different answers.
Did you guys get C11 and D5?
Yeah.
Okay. What did you guys write?
You're super confident.
Sorry,
I like it.
Fletcher.
Okay, I'm going to start by simplifying within each parenthesis. So this first one, I'm going to have C squared D all to the negative 2.
Oh, I had that.
Yes?
Oh, I had that.
We're okay with that?
Wait, is D to the 1 with J?
Yes, that's fine.
No, I had that. Okay.
All right, the second one, I'm going to get C to the 5th
Oh, yeah.
over D all to the 3rd.
Oh, see, that's why I messed up. Okay, well.
Yes? Okay, baby steps. You didn't have to do it exactly this way. There are different ways to get to the end. So this, if I multiply, that's really C to the negative 4th and D to the negative 2nd. Or I could just do 1 over C to the 4th, D to the 2nd. Are we okay with that? Yes? And this becomes C to the 15th over D cubed. Yes? Your final answer, whichever route you took, should be C to the 11th over D to the 5th.
I got two as well.
I got 11 then 6. So it's really interesting.
On the bottom, did you multiply instead of add?
I might have. But it's hard to happen.
Oh, you did multiply.
I'm not. I don't know where to look. Those are my words.
Okay.
They all kind of look the same.
Okay.
I have no idea.
Does it make sense? Okay. All right, let's try again. I'm going to give you coefficients this time.
Oh.
Because that makes it harder. It's example 2. You can't be giving up on example 2, okay? Let's do 3 C squared. Let's go to the. I won't be that mean yet. Let's do cube. I know, I'm going to give you some fractions here soon, but not yet. First one was not bad. Come on. It was pretty bad. All right, 3. Let's make it 6. 6. Oh, I know. A squared C to the 5th over B cubed negative all to the negative 1. That's what happens when I make them up on the fly. They get exciting. Maybe that's not the right word. I don't know.
Your feet, or one question, like one of these.
What about it?
You just make those like pretty solid. I like it.
I've been teaching pre-calc for a while. There's a lot of problems floating around in my brain, so. This is pretty similar to the first one. No.
Is it 3 plus?
6 to the negative first is not negative 6.
It's 1/6.
Yes, 1/6. It's not 6 times negative 1, 6 to the negative 1. That's what I mean. We're putting all of them together, throwing coefficients in, it gets ugly. Talk to each other.
That's a 9.
No. I'm saying negative. It's fine, take your time.
3 times 3. Do you want to
I'm just going crazy.
No
I
way.
think I just do it.
Bulldozer.
What's that? I just do it
No.
You would have to do a answer.
Really not sure. It's not really.
37 plus 6.
Wait, what is it? 27?
And it's to him,
Yeah.
Everyone has a good, because 3 to the third is 27.
You're on one place.
Yeah. 6 is on the bottom.
Wait, so you have a fraction on a fraction? Wait. Or is it, would it be 1/?
I'm just doing this.
So it'd be 27. 1/6.
Times 6.
Or no.
Oh my god, 6 is down there.
Oh.
But I haven't got there yet. We'll see. Wait.
Oh, 8 A, B, 2B. What?
Full.
And then it's you as well. So she like goes more things than you do. But then when it's
Oh, it's a regular number. How does it get to do that?
Why not everything?
You're on here. Yes.
No.
Yes, that means you're on
Coefficients make it harder, doesn't it? Yeah.
We're doing 80 times 1 a bit.
I think I'm safe.
Wait, where did you get this?
Okay, did you get?
I do.
You got these 3 over 6.
You know, you wouldn't have a calculator for this, right?
I enjoy
Alright guys, let's look.
No, wait, no, wait.
Alright, so I'm going to simplify one parenthesis at a time, figure out what's happening here. So 2 cubed is 8. This would be a to the 9th, b to the 3rd, over 3 cubed is 27, c to the 6th. Yes. Okay. Second parenthesis. Oh, yes.
Why would it be 8A6? Because it's cubed. and you use
Power to a power.
Right.
Power to a power you want.
Because think about it. It means there's 3 of those a to the 3rds. So that's a to the 9th. The second one, it's all just raised to the negative first power. That just means it all gets flipped. So the b cubed comes to the numerator. 6a squared c to the 5th goes to the denominator. Okay. You're there. Okay. Let's deal with all of our coefficients first. So off to the side, let's think about it. I have 8 over 27 times 6. I don't want to multiply 27 times 6. How about I reduce first? What can I divide 8 and 6 by?
2.
2.
Good square root of the third. Oh, 8 and 6. I thought you meant 8 and 27.
So I get 4 and I get 3, right?
What?
3 times 27, that's just 81.
Yeah, 81 squared.
So I know I'm gonna have, why? So I know that's where it starts.
I didn't want to reduce it, so
All right, then you can work on your variables. So if I look at the A's, I have a to the 9th up here, and I have a to the 2nd down here. So how many A's do I have left, and where are they? A to the 7th. B. I've got a b cubed and another b cubed in my numerator. So what is that? Yep, all in the numerator, right? Then my C's. That's a 6, yes. Doesn't that look like a 6? Right. All right, your C's. C to the 6th and C to the 5th. What's the denominator? That is your answer. Who got it? Oh, a lot of you got it. Okay. And those of you that made a mistake somewhere along the way, does it make sense now?
Yes.
Yes? Okay. All right. I'm going to give you another one. Let's see.
Is when you're doing figure out
Yeah, what is this?
All right. A little trickier. You sound very sad.
Oh, is that
How are we doing, guys?
like something weird.
I'll let you know.
What does the 1/3 mean?
Cube.
Cube root. Okay. You have to simplify a cube root.
You know what? That's so nervous. I'm good, sir.
E to the 3rd, not twice squared. The A. That's right. Well, no. Yes. I was
So we just
I know I'm doing that.
put that in there.
So it's on, they go, well, it's on, yeah, so then, yeah, and it's like
We
first.
still answer.
Yeah.
Okay, so that means.
And then it's all, so what, except for goes into 16. You can all, no, yeah, so you take out.
All right, you guys are doing good with this.
Do you want us to make it a brush, can we just keep it over there?
Just radical.
And then one, seven.
All right, guys. If you're struggling with this at all, I would do it in pieces. The coefficients are different than the exponents. Okay. So think about just the cube root of 16 to begin with. I don't care how you simplify radicals. Kind of like factoring, as long as you do it correctly. I don't care your method of getting there. Some of you make little trees and circle a bunch of numbers. Okay, as long as you get things done correctly.
That's the Matthew special.
Or if you could think of a perfect cube that 16 is divisible by. That is Leaves it, yes.
Awesome, that discussion.
Right? That's the same thing. And then you just take the cube root of 8. I don't care what you do in the middle as long as you are getting to that at the end point. All right?
How was that?
That's not the answer. All right, then what we're thinking about with our variables. This is like a to the 5/3, b to the 9/3, right? That's kind of what you're thinking about. You're thinking division.
Yeah.
So how many times, let's start writing our answer here. How many times does 3 go into 5?
Ones with
Once with a remainder of 2. How many times does 3 go into 9? 3, no remainder. So that is your answer.
2.
Okay?
All right.
We need more of those, right?
No.
I think we need more of those.
So the A just like.
You can say hi to them.
I've had 2 cups of coffee, also water bottles, and right now it's
All right, let's try again. Let's see. All right, I'll give you one with fractions, exponents, and multipliers. Okay, we put everything together.
I'm ready.
All right, let's do it.
This is you.
Just like this.
Sure. Are you?
I'm close to having
A little bit until this next problem, I think.
But won't you be excited if you can do this next problem?
He's gonna look at my answer because I'm not finished recording.
Okay. I gotta figure out what all I want to make you do on this stuff. So.
Throw me a curveball so I feel like stressed. What would I not want? That's physics and shit. Like, oh, you
I went to,
oh yeah, you went and then they asked like,
They did.
and then the one time I didn't work, actually.
I went like at 1 and don't know what to do.
Yeah, she was like, there's like, two girls came by and asked me.
Well, 3 girls. Like me, I know they said that, but I don't know like I'm doing it. And they're like trying to hide.
Yeah, they tried to hire me. They're like, we need more people. Like,
Yeah, really? I don't do.
like, I don't
And I was
know.
like, I already know how it works here, but then, yeah,
All right. There you go.
Oh, that's not bad.
It's not that bad. You can do it. Flasher, ready, go.
Actually, that's pretty hard.
It's a little weird. There's definitely a harder way and an easier way to do this one. Yes. Thanks, you're great. Later in the week, if you look at it more next time, okay? So when we said do the half at the end, you can't multiply.
I need to organize this one. It's not working.
Okay. That makes sense. It's okay.
They're closed a lot when I'm stressed. We're still there. I got you.
I just like simplified.
Wow.
Those, like,
I don't know what you just did.
okay. Yeah. Yeah. But I don't know if I'm getting it right. Oh, wait, sure. To the top.
Actually, it's review.
Alright, guys, let's look. Yes. Are you sure? That was a very like enthusiastic. Okay. All right. It is much easier if you simplify this one in parentheses first.
Let me know when you find out.
I forget to simplify too. I did.
Whoa.
All right. So the first one, I reduced everything before I did the square root. Okay. Second one, I flipped and squared my everything. Okay. How about 6? I did the square root before I thought about it. Was getting ahead of myself. All right, so when I do the square root, I'm left with a b.
Oh, before I see that.
Square root of a, right? And then a c cubed. And then we have this. Yeah. Ooh, 6. Keep me honest here. Better?
So you multiply.
Yeah.
You
Okay.
square root everything before you multiply.
Yes, because you can't multiply them and then square root it because they aren't both under square roots.
Huh.
So like if I think about it, if I have 3 times root 2, that's not root 6, right? Okay. Nice. So when you simplify this, I know I have an 18 in my denominator. What do I have in the numerator? C to the 7th. Then it's kind of weird. I've got a to the 4th, b to the 5th, square root of a. That's what's left in my denominator.
Yeah.
I'm not going to make you rationalize that. That's it. Okay, how'd we do?
But if you rationalize it, what if you take the 7th a square?
Square root of a over 18. Yes. That is a weird looking square root. That would also be okay. Okay? This is if you rationalize, multiply square root of a, both numerator and denominator, which makes it a. And you, like, as the year goes on, I'll tell you if you need to rationalize or not. In calculus, you don't have to rationalize, so we don't rationalize much in here, okay? All right, feel okay about that? Okay, phone's away. It's not phone break time, guys. Fletcher. All right, let's try. All right, I'm going to change the directions on this one. Write using rational exponents. What are rational exponents?
Like 1/2.
Yes, exponents that are fractions, right? Okay. So let's do
What's your ratio?
the fourth root of 16 s to the 12th t to the 15th.
Is that a T?
The t, yes.
Have I said C? And I was like,
Oh, that is not. All right. So first, when you're doing this, always treat the coefficient a little bit differently. What is the fourth root of 16? 2. Okay, that worked out nicely. Then if you're doing rational exponents, all you have to do is take the variable, and it's 12 over 4 for s. And then t is 15 over 4. So simplify if you can. So it's 2s cubed, and then that's just t to the 15 over 4.
I would have got that exactly.
And that's it.
Awesome.
Okay, they're kind of weird. You just need to know what the directions mean with some of these. So now we're going to go in the other direction. So express using a radical. So in my final answer, do you think I'm going to have fraction exponents this time? No, I'm going to have like a root thing, right?
Yes.
Okay, so let's do 12a to the 2/3, b to the 3/4. I'm going to walk you through this one.
Did they completely the same,
Don't say it, yeah.
did they get the same, like, denominator?
Yes, so the two fraction exponents, you need to make a common denominator. That common denominator is then the root that we're talking about. So I'm going to just leave the 12 alone. What is your common denominator? 12. So do you guys agree A would be to the 8/12 and B would be to the 9/12? 9/12. Somehow that's hard to say. All right, now you're 12 out in front. I realize there's a lot of 12s happening here. If you want to put it under the radical, you can't just put just a 12 under the radical. So there's two different ways to write this. You can leave the 12 outside and then say the 12th root of a to the 8th, b to the 9th, okay? Or if you think the 12 looks lonely out there, if you're going to bring that under the radical, it's 12 to the 12th, a to the 8th, b to the 9th. Yeah, I don't like that as much. I would do this. But this is correct, okay? Like, I would accept that. Do you guys see why just putting a 12 under there is not okay? Yeah, because that's the 12th root of 12, not just 12. Okay, does that one make sense? Want to do one more of those? Okay, so we'll call this one A. Let's do 6x to the 3/5, y to the 2/3. Try that. 3/5 and 2/3. Let's see how you do.
What are you talking to? Why do you talk?
All right, guys. So, did you leave the 6 out, or did you put the 6 underneath? Out. Okay, let's leave them out there. What is your root? 15. X would be to the good, and Y to the okay. How many got it? Okay. Let's do. What else do I want to make you do?
I look forward to 8.
All right, let's do just one more simplifying. I don't know, what number am I on? 7?
Well, that's gonna be 7.
Yeah, since I made it A and B. So let's simplify. Square root of 32, x to the 7th, y to the 4th, z to the 3rd. Okay. This is your last one for 2.1.
The square.
Square root, yes. Give me some time. So remember, 32, just do that on its own. Square root of 32, how you simplify that.
Sure, that's 4. And then coming in, that'd be 42. Because not just a little bit. And coming in, that'd be 16. So what? I'm so sure. I think 4 times 4 times 6. 4 is
Yeah. All right, so 32. Again, I think of that off to the side. I think 16 times 2. 4 root 2. We're okay with the coefficient part. Okay. So I know I'm going to have a 4 outside, and I know I'm having a root 2 underneath. Exit. So how many times does 2 go into 7? With 1 left over, right? How many times does 2 go into 4?
Twice.
Twice. No leftovers. How many times does it go into 3? Once with 1 leftover. That is your answer. How'd we do? Yeah? Okay, we feel okay about exponents?
Yeah.
Okay, you get a 10-second break while I open the 2 notes, okay? It's a busy day.